Okay, continuing on with v substitution, and we're going to go into another potential set of differential equations that could cross over into the stratosphere of being neither linear nor what we have as separable differential equations. Okay, and now for the next category, okay, within the alternate types of equations we might deal with that are first order, we have in the case of homogeneous equations. Okay, and a homogeneous equation is an equation that can be written in this particular form, where we have dy over dx is equal to the function where we have y over x. And if we were to apply, once again, the substitution variable v, and we set that equal to y over x, well, we can establish a clear pathway to finding out what we could have for the derivative as y changes with respect to x. So just refashioning v is equal to y over x and refurbishing in terms of isolating the variable y. So here we're going to have y is equal to v times x. And if we take the derivative with respect to x, okay, so left hand side, okay, you have d over dx of y, so we have dy over dx. And for v times x, we're looking at taking the product property. And so we'll have v times the derivative in x of x, and then we have plus, and again switching hands, we have x times the derivative in x of v. And so we have dy over dx is equal to, now again, the derivative with respect to x goes to 1, v times 1 is v, and then we have plus x dv over dx. Now, as a case of a homogeneous equation, and let's say if we have dy over dx is equal to 10x squared plus 7y squared over 2xy, and if I look at separating the terms, okay, so we have like 10x squared over 2xy, so you have a degree in x left over at the top and y is at the bottom, and 10 halves goes to 5. And for 7y squared over 2xy, that is going to be 7 halves of y over x. And again, letting v be equal to y over x. And we have this alongside the 7 halves. So we have setting up, so we have v is equal to y over x. And for the reciprocal of y over x, we have x over y. And so that's going to be the reciprocal of v. And again, with y is equal to v over x, so we're going back to this particular setup, okay, whereupon we have dy over dx is equal to x plus, or I should say v plus x dv over dx. And for what we have in the original equation, whereupon we had dy over dx, okay, we had 5 times x over y, and again, x over y is going to be the reciprocal of v, so we can say we have 5 over v, and we have plus 7 halves of y over x. So that's going to be 7 halves of v. And notice we have both of these equations in terms of dy over dx. So I can set these expressions equal to each other. So here we can say that we have v plus x dv over dx is equal to 5 over v plus 7 halves of v, and getting the x dv over dx by itself. So if I take v away from both sides, so right now we're going to have 5 over v, and 7 halves of v minus 1v, that'd be like 7 halves of v minus 2 halves of v, so that is going to be 5 halves of v. So putting together these terms on the right, so you have x dv over dx, and we have with least common denominator at 2v, and I'm just going to put the v term at the front. So you have 5v times v, so that'll be 5v squared. You have 5 times 2 is 10. Again, 10 over 2v goes to 5 over v. 5v squared over 2v goes to 5 halves of v. And now, looking at separating the variables. Okay, so I'm going to take the reciprocal on the right hand side and multiply on both sides, and also multiply by dx and divide by x. So now we're going to have 2v all over 5v squared plus 10 is equal to dx all over x. And looking at integrating, and I'm going to bypass the use substitution, okay, in terms of giving the explicit detail. Okay, but now I have the derivative of 5v squared. That would be 10v, and 2v over 10v is going to be 1/5. So the antiderivative is going to be 1/5 of the natural logarithm of 5v squared plus 10, and here we have is equal to the natural logarithm of x followed by the constant. Okay. And if I look at multiplying, say if I multiply by 5, okay, so you can see we have the natural logarithm of 5v squared plus 10, and we'll say we have is equal to 5 times the natural logarithm of x, and for 5 times c we'll just throw in, we'll say, the letter alpha, and just narrowing it down, so the natural logarithm of the quantity of 5v squared plus 10. And guess what? For 5 natural logarithm of x, I can make the 5 into an exponent. So we can see we have the natural logarithm of x to the 5th plus alpha. And looking at what we have in following through, okay, so if I take both sides as power, so which the natural logarithmic base e will be raised okay, so left hand side, okay, that would be 5e squared plus 10, and again for e to the alpha, we'll just make this into a constant, we'll say beta, and we have e to the natural logarithm of x to the 5th. This will go to x to the 5th. Okay, and so looking at what we have for v squared, again we had that v is equal to y over x. And I'm just going to get this by itself ultimately. So you have 5 over v squared is equal to beta times x to the 5th minus 10. Okay, so you have 5. Now for v squared, so you have y over x raised to the 2nd Okay, so now we have 5y squared all over x squared is equal to beta x to the 5th minus 10 and multiplying by x squared. Okay, so you have beta times x to the 7th minus 10 x squared. And so for what we're going to have in this particular case, so if I divide by 5, let's say we have y squared is equal to, and like beta over 5, let's say that's just going to be gamma times x to the 7th minus 2x squared. And we'll just leave this in terms of second degree. So you have y squared is equal to a constant, we'll say gamma times x to the 7th minus 2x squared.